Hello, everybody. Thank you for attending my presentation. The name of this presentation is ORM Framework. So as you can figure out from the name, it's not really directly related to Postgres. It is related to the interaction between application and the database. And in this case, the database is Postgres. So mostly it's related to communication between application and the database. And you might wonder why we are actually doing this. So why we are talking at the Postgres conference about not Postgres. The reason is that interaction between application and database directly affect the overall performance of the application. And at the end of the day, you know what? That's the only thing we care about. We care about how the whole application is performing, not just Postgres queries. And so let's address this topic. First of all, why we're even talking about performance, why it matters. You know, the application response time matters, and these days the old saying time is money is true more than ever. And I can show you how exactly time is money. According to researchers, here is money by the numbers. Amazon reported several years ago that 1 second page load slowdown resulted in loss of 1.6 billion sales annually. So I think it's like a decent number even for Amazon, and that was several years ago. Google reported that slowing search results by 0.4 seconds results in loss of 8 million searches per day. So those are definitely huge numbers for the revenue. But what is more alarming are these two numbers. According to researchers, 50% of visitors abandon the site which is not loaded within 3 seconds. So we became very impatient. We cannot even wait for 3 seconds for website to load. But what is more alarming is that out of these users, 79 visitors will never come back. So we do not lose them even once, we lose them forever as our potential customers. So looking at these numbers, you understand that response time is critically important. But we all use internet, and we know that many companies cannot really keep up with this user demands. So quite often, instead of just, we log to the website and we see something, instead of this we see, wait. So what is the reason for this worldwide wait? All right, and I will tell you in a second why we wait. Welcome to ORM. So that's the name of our worst enemy. Our worst enemy is called ORM, which means Object-Relational Mapper. And what is ORM? ORM is the software, the program, which application developers use to communicate with database. Why they use ORM? Because they do not want to run SQL queries by themselves, and they want some level of abstraction between application and database. ORM solves this problem of abstraction, so they can abstract from details of data storage. But unfortunately, there is one thing ORM cannot do. ORM does not provide efficient means of manipulation with data sets, which is the power of relational databases, including Postgres. So what we have? In the application, on the application side, we have application model. On the database side, we have a database model. And these two models are like faraway galaxies. They do not even know anything about each other. On the application side, we have object-relational model. On the database side, we have database model, which in Postgres case, it's object-relational. So what happens then? And we have, they think they talk, they don't talk, okay? So we have flat tables on one side, flat tables on the other side, and we have JDBC. So in case our application is Java application, then we have JDBC, and JDBC can only transfer simple scalar types, and all the queries from the application side are flattened into these flat tables, and then they are transferred through JDBC to the database, and then they are transferred back. And here is our friend ORM, or our worst enemy ORM. So ORM does this job of mapping of the object-oriented application model into these flat tables, and then getting this data, small little queries, getting to the database side. Database actually can do better than doing select star from table A, select star from table B, but we do not have this option. And then all these responses are shelled back to the application. So this data transfer becomes real bottleneck, and we'll see something like this. No, data cannot go there. So that's not a good situation. And even we have fast disks become faster and faster, and networks become faster and faster, we still have this problem because we cannot use the fastest networks, and we cannot use fastest disk efficiently while we are transferring data from application to database and back in this archaic phase. So that's our solution. That's why we came up with NORM, No ORM Framework, which we hope will become new norm. So again, we have application object-oriented model, and we have database model, which is object-relational. But what we do here, we are not transferring these models on one side. Instead, we suggest the intermediate transfer model. And this mapping is symmetrical. So both applications maps their model to the transfer model, and database maps their model. And this transfer model models all objects in JSON format because, let's be honest, there is nothing but JSON in the current world, right? Everything is JSON. So then we both can map our models to JSON, and then what happens? Then we can convert JSONs to the text files, because again, JDBC only understands plain text, but we know that inside this plain text is grammatically correct JSON. So that's what we're doing. We put this grammatically correct JSON in the plain text, and then JDBC transfers this to the database. Database interprets it as the JSON object, and then when results are ready, it sends it back. So everything is symmetrical, and everything just transferred from complex model to complex model and back. Now, application developers like the concept of contract, and we decided that we can adopt the same concept to the interaction between application and the database. So that is our contract. Both sides, an application and the database, convert internal representation into complex hierarchical objects, and contract establish the object structure implemented on both sides. So we both know what is the structure of an object. And now, for any application endpoint, it takes one database call to transfer data to and from database. Okay, maybe not one, maybe two, maybe three, but not more than that. Not like tens, not like hundreds, and sometimes 1,000 database calls per one screen rendering, as it often happens when we use object-relational mapper. So that's like the idea. Now let's see how we implement this idea with a little bit more details. So let's say in the database, we have this like very simple database schema. We have a table account, then we have table phone, we have table email, then we have email priority and phone type. So each account, and everybody have account, any application has account, right? Okay. So each account might have multiple emails, primary, secondary. Each account might have multiple phones, Phones might be of different types. Yes, these days, most of the time, all phones are cell phones, but still, somebody might have landline, somebody might have, God forbid, work phone, or like, I don't know. Anyway, so that is our simple database schema. Okay, and here is how our transport object looks like. So we have account record, and we have all the scalar values here, and we have phone record, and there are multiple phone records, and there are multiple email records here. Now, that is how this transport object will look in JSON format. So you can see that it's just perfectly, correctly formatted JSON. And that's what we're going to achieve. So on both sides, on the database side and on the application side, that's our transport object format. Now let's see how we can do it in Postgres. So now finally, 10 minutes into presentation, we are getting into Postgres. So how we are doing it? First of all, we are creating user-defined types. So great thing about Postgres, we can create user-defined types of any complexity. First, we create phone record type, we create email record type, and now the best part is that Postgres allows us to create complex user-defined type with embedded user-defined types. So in account, we have the scalar values, and then we have the arrays of phones and array of email addresses. So great, we created exactly the object which we need. And remember, we still, in the database, we still have tables. We do not have any complex objects. So these objects are built for transport. And in the database, we still are dealing with relational tables. And by the way, why? So the question might be here, why we are doing this? Postgres is absolutely capable of storing JSON. So people put lots of effort into creating all this JSON support, JSON functions, indices. So why in the world we want to go into this complexity and why we cannot store JSON? So there are two reasons for this. First is the power of relational search. Okay, not maybe completely lost, but at least searching in JSON, even if we use all these new indices, thank you, Andrew Dastan, still the search in JSON is not that fast as in our old good relational tables. And remember, response time matters. We are fighting for seconds and milliseconds, so that matters. That's number one. Number two, important thing, when we use JSON as a return type, and in a second, we will start to create user-defined functions, and we will know why it's important. So if we return JSON, they are not typed, okay? There is no JSON type. Type is JSON. So we cannot create strong type dependencies. And we need to create strong type dependencies because contract application expect us to return data in very specific structure. It should be integer in place of integer, date in place of date. And by the way, they also should be named properly. So we need to make sure that we always return the expected type. And we cannot do it unless we define the strong types in the database. So again, in a little bit in this presentation, I will show you how we create packages. So everybody who worked with Oracle before know what I'm talking about. Postgres does not support packages yet. I strongly hope that it will happen sometime, but for now, we are just emulating packages. So we store the type definitions and all the functions which work with this type in one file so that we can have them all together and make sure that we modify them accordingly, simultaneously. And by the way, you cannot modify type without dropping all dependent objects. So again, thank you, Postgres. Everything works perfectly together. And that is our solution, how we build this type. So that is a SQL which we will use in one of these functions in the example, but now I want to show it separately. So here you can see how we build this record as an output. So we search for specific account using the P account ID as the parameter, which we pass to this function. And we select the account from the account table. And then in select list, we select all the associated phones and all the selected associated emails. And then we build this type by converting the embedded objects to the corresponding record type. And then we return a row of exactly the record type we need, row of the type account record, okay? And then one last thing. So when we built it, we built just a complex type. So this would not play well if you try to send this over the wire to the application, because application would not understand it. So first, we need to convert this type to JSON, and second, we need to convert this JSON to plain text presentation, because otherwise JDBC won't be able to transport our JSON. So how we are doing this? By this transforming function, which is called array transport. So you can choose whatever implementation you need. You need this one function, array transport, which will convert all of your outputs to exactly the way how they can be transported from database to application. All right, and we will see how this function is used in a little bit. So like once again, that's all the function you need. Now, after we looked at all this, let's go to the example. So it was promised to be tutorial. So let's look at the example. You can do this again by yourself if you go to this GitHub repo, which is called NORM. And this example is there in this repo. So now I will just briefly go over this repo and we will see like step by step how you can build it and how you play it with this example, and how you probably can build the functions which you need for your application following all these steps. All right, so first thing to do, we are in this NORM GitHub. So we need to go to the SQL subdirectory. And as you can probably guess, we need to go to the load all. So load all file, if you just run it, it will create everything you need to run this example. So you can try it by yourself. First, it will run this create tables, and what it will do, it will create schema norm, and it will create all the tables which we've seen on ER diagram, and it will populate all this like original stuff. Then next thing, it will create the function array transport. So you will need this function to make sure that no matter what types, what user-defined types you will define, they will be converted. And then the last one, it will populate initial setup, because we needed to run our example. So it will create 3 user accounts, it will create 2 emails, and it will create 2 phones. So each first 2 accounts will have 1 email, and then 1 account will have 2 phones. All right, so that will be it. And now we are ready to look at more complex stuff. So more complex stuff is how we build a package. So in GitHub, you will see account package, and that is an example for you to build your own packages for your application. First, we start from creating these user-defined types. We just saw them on the other slide, so the same thing we're creating here. Then we create the function which will create user account. We receive this information from application. Application has JSON, so application passes JSON, because again, that's all application knows. And what we're doing then we parse this JSON and we see what we got. So some of these keys are application account details, some of them are phone details, and some of them are email details. So we insert the application record, then we know your application ID, then we parse all the phones and all the emails, and then we insert them. And at the end, when we are done parsing, we are done inserting, then we return new user account, because now we created it and we can return it. And now let's see how we wrote this function which returns application. So the function is called search by ID, and that is the same SQL you just saw how to build this account object. So we built account object by ID, and we are ready. And then one more thing, we need now to transport it, to transfer it into JSONs, which are converted to text. So this function with another name, which is called select by ID. So the difference is that is the function which will be created, which will be called from the application. Now, next one. Next one is account search. Now we want to see how we can search account using more complex criteria. All right. Not by ID, because it's not interesting. We want to search by any criteria. Again, we receive search JSON, because again, that's all how application talks to us. And in this search JSON, we analyze it same way, we parse it and figure out what are the search criteria which are passed for us. And then we format 3 search criteria. One for the search in the application table, another for the search in the fonts table, and the third one for the search in the emails table. Then in each of these tables, we select all account IDs which satisfy these criteria. And then after we got all these accounts, then we can search in the account table. And again, we can build this JSON which will satisfy all the search criteria here. And we are done, and we are ready to select. There may be one, there may be multiple, whatever, but yep, now we selected all these accounts. Now, next thing, now let's look at update. So update is more complex function. So why it's more complex? Because for the elements of account, we need to update, but then we also need to update fonts and emails. And it is possible that we not only need to update them, but we need to insert or delete emails or fonts which are associated with this account. So that's why this function is very complex. Again, we parse the JSON, which we receive as the parameter, and we see, okay, so if the keys belong to the account table, then we update account table. But if we have something which is associated with phones or emails, our job becomes a little bit more complicated. So what we need to do, in addition to these values, we also have the JSON key command. And the only thing we know about this command, it may be delete or nothing. Otherwise, we just ignore it. So if phone has the phone ID, that means we have this phone and we want to update it. If it's a new phone, we do not have ID. And if command is delete, we are deleting the phone by this ID and ignore the rest. And we are doing exactly the same thing with email. So again, email can be inserted to add it to the account, or it can be updated, or it can be deleted. And when we are done with everything, then, so we are done, and when we are done with everything, we will select the final result. So we updated. If we try to update, it did not work. Too bad. We will update nothing. If we try to delete and nothing happened, again, too bad. We will just, get nothing. But whatever we got, we updated or inserted or deleted. All right. And now it's more interesting part, most interesting part, right? So now let's look at the examples, because now we have this like big example which we built, and now we will execute everything what we have in this examples file. So first of all, number one, let's make sure that we have all we need. So we will see what we have in user accounts. We have 3 user accounts. Then let's see what we have in fonts. We have 2 fonts, and then we have emails. We have 2 emails. Okay, great. Now let's proceed with all of our examples. So all the stuff is in examples. So we are making sure that we are in the norm folder. The next thing what we are doing, we are creating new account. So we call function create account. That will be a new function, and you can see that the account ID is 4. So we created function, we created new account. Great, nice, beautiful JSON, wonderful. And then what we're doing, so we are done with this function. Now we are selecting. So I want to show the difference here between search. It selects the same thing, just the output is ugly. And then we will call the function which is select ID, same ID. So you will see that it will select the same account. However, the output looks nicely. It will be grammatically correct JSON, and life will be great. Okay, wonderful. Now, next. Okay. Now we are doing a couple of selects. So we are playing with different search criteria, and some of search criteria, you can see that some belong to user account, some belong to email, and some belong to phone. So let's see how different searches work. So no matter what we pass, so here we have two accounts. Right here we are searching by user account and phone, and we receive the phone. Wait, and next. So next one, we search all the by phone. And next one, we search by last name and email. Great, beautiful. Okay, now we are calling update twice. So first we are updating username or user account ID 1, and great. Okay, we got one bit updated. Okay, wonderful. So everything is beautiful. Next one. We are updating phone, and by the way, you know that phone ID 4 does not exist. So let's try to update phone with phone ID 4. So we are highlighting this function, and we are updating, all right. So we are updating this one, and let's see what will happen. All right. Nothing will happen because, okay, so user account was 4, and we updated and we got nothing because there was no phone with phone ID 4. So nothing happened. Oh, you actually, sorry, my mistake. We should not update, we should insert the phone. So now what we're doing, we're calling again user account update, and for the same user account 4. But instead of update, we are creating new, because now phone does not have phone ID. So now we're saying we do not have this phone, please add this phone. All right, now the situation is much better, because now we have 4 phones, phone with ID 3 and phone with ID 4, and everything is great. And now let's do one more update. Now we want to delete the phone from the account 1. Unfortunately, this phone ID exists. So what happened after we updated, deleted the phone? You can see, all right, account 1 now has 1 phone. It used to have 2 phones. So now we tested all the possible situations, insert, update, and delete. And okay, the last one, we want to add email, because this account does not have a mail, unfortunately. So account ID 3, let's add email. Again, the update account, but this update is that we're adding email address to this account. Let's look. Great. Everything looks perfect. So now this account has everything. Wonderful, right? So we are done with this update, and basically we are done with this tutorial. So yep, thank you so much. Yep, thank you for attending, and questions in chat, and I'm actually present here. So thanks a lot.